Okay, so the next module we'll be talking about is the next concept we'll be talking about is collision theory. Collision theory is essentially the interaction between atoms and how they collide with each other, which in turn leads and stimulates the reaction. So the first concept is activation energy, and activation energy is defined as the minimum amount of energy that colliding particles must possess for a collision to result in a reaction. So to visualize this, we can have an atom here and an atom here, and when they collide with one another, they'll collide with a certain amount of energy. If this energy is very little, it's unlikely that it will lead to a reaction. However, if it's a very forceful reaction, um, with a high amount of energy, it's likely to have surpassed the minimum amount of energy or that activation energy value, which in turn leads to a reaction. So this is an important concept, and of course, the units of activation energy are measured in joules, but usually they're quite high. So we'll see them often stated in kilojoules, which means 1,000 joules. And the symbol for activation energy is EA. So there are 5 factors that need to be met for a reaction to take place. The first one is concentration, or there are 5 factors which actually affect the rate of reaction. Concentration, the pressure, surface area, temperature, and lastly, the presence of a catalyst, which we'll explain more in detail soon. Okay, so the first factor is concentration. So if there's a high level of concentration, there's likely to be a high level or a high rate of reaction. This is because there are a lot of particles within the solution and within the reactants which are ready to collide with one another, leading to a high rate of reaction. Next is pressure. Pressure is, of course, the measure of density of a gas. You could say that. And if there's a high pressure, there's a lot of force on the gaseous particles, which would also lead to more stronger collisions, heavier collisions, and likely higher a rate of reaction. Next is surface area. If there's a surface area, means the amount of area the particles are exposed to within the solution. So let's say there is a block of calcium. If it exists as a block, there's only if it exists as a cube, let's say, there's only 6 faces that are exposed to the solution. Whereas if it exists as a powder of the exact same mass and volume, there's so much more of that surface area exposed. So the higher the surface area, the higher the rate of reaction. So since there's more exposed, more collisions between the calcium and the solution can exist and take place, leading to a higher rate of reaction. Next is temperature. If there's the temperature, of course, is the measure of the average kinetic energy of the particles. And if there's a high temperature, the particles will travel with the higher kinetic energy, which means they will be traveling faster, and they're also likely to be traveling with higher energy, of course, which is perhaps higher than the minimum activation energy threshold. So with higher temperature, higher energy, and thus a higher rate of reaction. Finally, a catalyst is, the presence of a catalyst is essentially a tool that's used to speed up the rate of reaction. So if there is a catalyst, it's likely to increase the amount of collisions and speed up the rate of reaction. So if there is a catalyst, we're likely to see an increase in the rate of reaction. So the purpose of a catalyst is essentially to reduce the activation energy. By reducing the activation energy, it can, although although it won't necessarily increase the number of collisions that take place, more collisions would be considered successful. So this phenomena that a catalyst embodies can be shown through the Stefan-Boltzmann curve. This is a very rough diagram. So this area is the area of successful collisions, and this is without a catalyst. However, with a catalyst, there'll be a lower activation energy, but the area impacted by successful collisions would be much higher, leading to a higher level of collisions and thus higher rate of reaction.